share my screen right there. Can you just give me a shout if you see it properly?
Yeah, it's okay.
Yeah, nice. Thank you very much. Let's go. Well, thank you both Johan and Alexandre for your invitation. It's very nice to be back. Last time I've been here, it was with Johan actually, last year, I think. So yeah, very happy to be back. And today we're going to talk about exceptions. Well, maybe, or maybe something else. And you may have one question at the moment is, who's this guy? And so my name is Guillaume. I am a .NET developer advocate at Vonage. And here you have everything you need if you want to connect. So you have my LinkedIn account, you have my GitHub account if you want to look at what I usually do. There is an additional GitHub account there, which is a free organization that I created with a friend called Johan Thirion. You may have heard about this guy. It was all about sharing what we know about Craft, XP, TDD, and all. So feel free to take a look. Everything is free and open source. And I'm currently also the co-organizer of the Software Craft Luxembourg meetup. So I come here as a friend. We are still operating online. So if you want to join, you are more than welcome. So yeah, that's basically me. So now exceptions. What is there to say about exceptions? I'd like to ask you something. So if you can just answer in the chat, I would appreciate. Have you at least once in your career handled an exception, whether in Java and C# or anything? Let me know in the chat. I'd be curious to know. And while you're at it, I'd like to know if you enjoyed it. Just saying. So we're going to start from the basic. What's an exception? Everything you see on the screen right now comes from Microsoft documentation. What used to be MSDN, it changed. But basically, they tell us that an exception is here to deal with an expected and or exceptional situation, and they provide a code snippet on the right that display how to deal with that in case of a division by zero. So they have a method called save division that throw an exception if you are providing a zero as a second parameter. And if so, the exception will bubble up until it meets a try-catch block somewhere and provide a secondary behavior. I think for all of you, this is very straightforward. This is trivial. And I agree, but I already have two problems here. First off, I don't know if there are any TDD practitioner in the room. I would expect so. So question for you people. If you were about to test the code we have on the right, the save division, we agree that you would expect an exception somewhere in your test, like save division of 50 by 0 should throw an exception of type divide by 0 exception. So why is it unexpected? It's not. And especially every exception that you throw manually in the code, every throw that you put there is not unexpected. You put it there in the first place. Also, they mention exceptional situations, but what we have here is basically a guard clause, and we are verifying what is basically a wrong user input. A wrong user input is everything but exceptional. They are fairly common. So I agree with the definition, but on the other hand, I disagree with the example they gave. But anyway, let's move on. Why do we use exception after all? Well, first off, they're very easy to use. You just throw something. Everything after that is not going to be executed. My IDE is already telling me that on the snippet you can see here. And the exception will bubble up until it meets a try-catch block where the exception will be handled. So easy to use, just throw and you're done. That's cool. They also can carry information. By information, I mean two things. First off, the type. and the type is already very meaningful. If I tell you null reference exception, you know what it is. If I tell you not implemented exception, you know what it is, etc., etc., etc. You see the type, you are kind of already able to know what happened and maybe why. And they can also carry content. So you have an exception class, a base class, sorry, that contains already tons of information. And every specific exception will contain its own specific information as well. So yeah, if you want to explain why it happened and provide like a graph of object or whatever, you can, and that's great. Obviously, you can make your own. That's nice. And they exist in various language and framework. So they're great. We should use them everywhere. And end of the talk. Thank you very much and see you tomorrow. No, obviously no. They are great for some things, but they also have major drawbacks. And when I ask people about exceptions, like what the main trade-off, what the main problem with it, people usually say performance, which is wrong. There is a cost when you throw and when you catch, but it's fairly minimal. And unless you work in IoT or a very heavy computing algorithm, you won't see the difference. And what I'm saying here is performance should not drive your desire to use exceptions or not for something. Okay? And I see actually a much bigger problem than that. And the first one I want to display is transparency, or at least the lack of transparency. We have here, oh, by the way, something I didn't mention, all the snippets we're going to see in the talk are in C#, but don't be afraid if you've never done C# before, because we're going to stick to the basics. The most fancy stuff we're going to use are generics. Yeah, so should be easy to follow. So yeah, we have an interface here that basically reproduce what we had in the previous example. So I can divide that offers a decimal, a divide method with 2 decimal and return the decimal. One question for you, what happens if I see an instance of I divide somewhere in the code base and I call divide of 50 by 0? There is one answer. You don't know. You don't know because it's an interface and you don't know how it has been implemented behind. For example, for whatever reason, someone might decide to return a default value like 0 or a magic number for whatever weird reason, or it can throw an exception. And in that case, which one? A custom one, divide by 0, the base exception one? You don't know. And I'm sorry to tell, but everything you see on the screen are valid implementations. Okay? So even some of them might be weird. You just can't tell when you're looking at the interface or at the method signature itself. And I have a funny story about, well, funny. Yeah, we'll see who laughs after that. But a story to tell about that, because last year, so I joined Vonage and I had to pass a technical interview, like all of us. And I was supposed to play with our SDK and our APIs and do something with it. And at some point, I'm supposed to create what we call an application. There is a typo in that, and we don't care because it's not fixed yet. But what matters is it's supposed to return an application, an asynchronous application. But wait a minute. This is an HTTP call to an API. So by design, it can fail. So what happens if it fails? I don't know. Exactly like before. Now, I consider myself a lucky guy because the SDK is actually open source, so I can go there, look at the code, and find by myself. So I'm brave and I'm trying, and that was a terrible idea. So basically, what I find is methods with try catch block where the catch block throws another exception. I see switch case statements where every case is basically throwing exceptions and sometimes different one. And I see try catch block that requires for me to stack 3 screens on top of each other to see the entire method. And it's basically the whole spaghetti code with meatballs parmigiano, the entire dish. And I just can't do it. So what do I decide to do? Fall back, change of plans. I try to brute force my way through the SDK. So I try a set of different scenarios where I'm going to provide null or an invalid request or invalid credentials, anything. And what I realize is I get a non-reference exception sometimes. I get a Vonage exception, an HTTP request exception, authentication exception. I mean, the entire set of possible exception I could get. And that ended up being a very frustrating experience, while the only thing I wanted to know is what to expect, because I don't want to catch the global exception type. I want to be precise and know what to expect from something. And I was not able to do it. And so what were the feedback I gave at the end of my assignment was that what you see here is basically what was in the README of the repo I gave. And I mentioned that the signature is lying to us because it's not telling us everything we need to know in order to use the SDK. And I mean, it shouldn't have been such a painful experience just doing that. So that for me, the biggest problem on regarding exceptions. It's worth to note I still took the job. So yeah, think what you want about that. Other problem I see is it's very intrusive. Basically, when you throw an exception in your code, you give the responsibility to handle it to the caller of your method. And what it means that the person using your code will have to put try catch blocks everywhere, because otherwise your exception will break its system. And that's bad. So what happened is, well, you got to catch them all. And you have tons of try catches polluting your code base. And one of the side effects I've seen is it started to generate paranoia in people. Because after that, when you have a code base that relies a lot on exceptions, people will start wondering when they see something, is it throwing an exception? And the normal behavior after that is, well, just in case I'm going to put a try catch, and you end up having tons of try catch blocks in the code base or huge ones. And that's not good, and that's not enjoyable as a developer. They are also very hard to follow when you have a full flow. What you see on the screen right now is a dependency graph that I found online. So let's pretend just for a second that this is simple to understand, because it's not, okay? And what happened is you can have an exception being thrown at the root level, right? And where did it happen? Again, you don't know. And my tip for you, don't look at the code base. This is a waste of time. Basically, it can happen everywhere. And I know what you're going to say. Yeah, we can have that from the stack trace on the exception. And you're right. The problem is the stack trace will probably end up in a log file that nobody watches. So that's one thing. And second, it probably won't be useful at runtime, because actually it's not really like the location that matters. It's more the state. What is the current state of the system? What I want to know is the system currently broken, or was the exception handled properly and we can continue going with what we have to do? Again, you don't know. And that's extremely difficult. When I see that, it brings some kind of PTSD from the goto era, because an exception is basically a sophisticated goto. I agree that it's better in the sense that it's unidirectional and it can carry information, but it has the same flaws. And it's also painful to play with. The last one I want to mention, and I like this one a lot, is most of the time, or at least close to always, it's just a GUAR clause. What you see here are examples from the SDK. And if you pay attention, every single time before throwing an exception, you have an if-else statement. And I think I would challenge you to look at your code and prove me otherwise. But basically, I don't think an exception is the right thing to do when you just have a failing if statement. I consider that a little bit overkill. And for me, it's like going to an ATM wanting to withdraw money, you put your card in, you type your code, and you do a mistake, and ATM receives an exception, it's done, and you can't withdraw money anymore. You know, it's a joke, but I mean, this is what I feel about it. So it's one thing to complain about exceptions and show that they are drawbacks and all, but where do we go from there? Can we do different? Can we do maybe better? I don't know. Well, there is something, otherwise this talk would be incredibly short and boring. So yeah, there is something, and now is the time for you to relax and don't get scared, because we're going to talk about monads. So please don't leave the room. I know that this is a term that is able to make people run away just by itself. What I want to show you is that it's just a fancy word for something relatively simple. Okay, we're just talking about a data structure that allows you to manipulate multiple contexts with functions. That's all. And Douglas Crockford used to say, at least he said that once at a conference, that once you know what a monad is, you basically lose the ability to explain it. And I agree, and I'm doing my best. And I think they are also a curse, because as soon as you know what they are, you tend to see them everywhere. And the reason is they are everywhere, and I'm not paranoid. Okay. So let's start from the beginning. What is a monad? And for that, I took a very simple description from a very reliable website, which is Wikipedia. Yeah, I assume right now most of you are like this. Okay. So what I'm going to do is I'm going to give you a personal definition of what they are. And in order to do that, I need to start with functors. And first off, you can imagine a functor as a box on which you can map a function. And this function can can transform a value that is inside the box. Okay? This is basically a functor. Why do we care about explaining what a functor is? It's because a monad is like a superpowered functor. It's a functor with something else. So please keep in mind that this is a very simplified definition. I'm trying to demystify all that, so I'm taking a lot of shortcuts. So if there are any hardcore functional people in the room, I apologize. Please don't throw me any potato or anything. You know, and what I want to make you realize it's not that difficult. And in order to do that, we're gonna start from a simple example, and we're gonna increment on it. And the example I chose is from quantum mechanics, and it's a simple one. It's Schrödinger's cat. I think you've heard about that before, or at least you may have seen sometime, at least once, a guy with a t-shirt where, you know, the cat is dead and alive at the same time. It's fun. Ha ha ha. Yeah, that's the thing. I used to have this kind of t-shirt as well. But anyway, it's fairly easy to explain. Imagine you have a box and you have a cat. This is my cat. This is Benji. Hi, Benji. The thing is, it's not your ordinary box like when you order something from Amazon and or any other packages, because the box contains two things. First, a radioactive element, and the second one is a mechanism that can release deadly poison at any time and without you knowing it. Okay? So the box is a bit special. There. And so what Erwin Schrödinger's perspective on that is basically that as soon as you put the cat in the box and you close the box, you cannot tell if the cat is dead or alive until you open the box again. A genius, isn't it? I'm joking about that, but basically what it means by that is trying to illustrate the concept of quantum superposition, where you need to consider that a situation exists in multiple states, sometimes an infinity of states, until you can observe a factual one. Okay, so many people tell that, oh, the cat is dead and alive at the same time. This is wrong. It's either dead or alive, but you just can't tell. Okay, so now let's look at some code because I was bored and I decided to code it by myself. So here you have a class which is called Schrodinger's box. So I want you to look first at the bottom. We have a static factory method there called with a live cat that takes cat as a parameter. Cat is a struct. Okay, so it's a value type, so it's not nullable. So now if you look at the top, you see that the field is nullable. We understand already something here. Thank you, Johan. And so basically, a living cat is an instance of a cat, and a dead cat is null. And then you can do, three things with the box. First off, you can shake it. Okay, the cat is not very happy with that. So what happened is we call meow on the cat. Calling meow on the cat will just log meow in the console. I know I was very creative with that example. I'm very proud of it. Something interesting, you see a question mark after cat. So if you're not used to that, this is called a null propagation operator. It just means that if cat is not null, we'll call meow on the instance. And if cat is null, we won't do anything. Okay, because a dead cat, not meow, it doesn't work. Okay. And then you can return the box. That's what shake does. You can also shake too hard. Okay. And in that case, same thing happens. Cat meows. But then you return an empty box, which means you kill the cat. Yeah, it's going to be fun, right? So yeah, shake too hard basically kills the cat. And finally, you can open the box and then you can receive a nullable instance of a cat to verify its state. You have no other way than open box to verify the state of the cat while the box is closed, okay? So all that for what? Well, let's look at some tests. That's the best way to show how this works. So basically, I have a box. I put a cat inside. I call shake, 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 and we see meow, meow, meow in the console. That's weird. What if I call shake, shake too hard and shake? You can see meow only twice because on the second one, the cat meows, then dies, and then when we call shake, the cat is not alive anymore and you cannot meow. And yeah. Finally, the last two, don't pay attention to the console, but it's just a way to show you that alive means instant and dead means null. Okay, I want you to pay attention to two things here. First off, we never manipulate the cat directly. Okay, we manipulate the box every single time. Second one is we don't have any branching. Whether the cat is dead or alive, we don't know, and we don't have any if statement to verify that or to have specific behaviors. Right now, it doesn't make much sense, but keep an eye on that, trust me, because we'll get back to that. Now, it's a fun example, but it's completely useless. I think we agree on that. So what can we do? Well, our box contains a cat. Cat is a struct. So our box could contain literally anything. Let's use generics, right? So we had dead or alive. We understood that it means null or instance for our cat. It won't work with like a dead time or an ENT or something like that. So we need to switch states, okay? And we're gonna use non-state, like we don't have a value, or some state, like we have a value. We still have this opposition of state. And what does it require us to change? Well, first, we still find our static factory method at the bottom, some that takes a generic, and we're going to create a specific box for that, or none that will create an empty box. And there is nothing interesting into, we don't have any interest anymore into shaking the box because it makes no sense. So instead we have something called map, And map is a function that takes a function as a parameter. Don't freak out. It's easier than it looks. So what we're going to do is we're going to use the function as a parameter. And if we have a value in the box, we're going to take the value, apply the function, and return that value into a new box. And if we don't have anything, we don't have anything. Struggling to understand? Let's look at something more graphic, okay? I have a box in my test where I put 3 inside. I call map value lambda value plus 1. This is a function. It's a lambda expression. So value is a parameter, and what we have after the lambda sign is what we return. So value plus 1. It's basically an increment method. Okay. So I'm taking my box with 3 inside. I unwrap the box on map. I take the value, which is 3, and I apply the function. 3 becomes 4. I put 4 into a new box and I pass the box around. Now, next map, open the box, 4 becomes 5, etc. 5 becomes 6, and at the end, I open the box and I should have 6. That's as simple as that, okay? What if I don't have anything? In that case, the box is empty, okay? So I can apply a function on nothing. No, nothing happens. None remains none. Very simple, right? So just to put that into perspective, I said before we didn't have any branching. What you have on the right is the equivalent if we didn't use any box. I already have my preference. Okay. Now it's time to celebrate a little bit because our box is now a functor. Remember the definition? Think of a functor as a box you can map a function over. Map, which means you can apply a function to what's inside the box. Yeah, that's map. Box is now a functor. Great. Now, I don't know if you were able to observe that, but our functor has one big problem. It cannot change the state of our box. If I have a box with a sum state and I call map, it will always return the sum state. And if I have a non-state and I call map, it will always return a non-state. That can be tricky. I wish there was something to do that, like, I don't know, a bind. Notice the difference between bind and map. They look very similar because they are. The only thing that changes is the content, the type of the method we pass to that. Map returns an instance of t-result because we basically transform our value. Bind return a result wrapped into a box. So bind will help us to basically change the state. I'm going to show you how. Look at the bottom. Here I have a half method. Basically, I'm verifying that the value that is given can be divided by 2. If it is, I return a sum value with half of the value that was given. And if it cannot be divided, I return none. Now, first example, I create a box, I put 8 inside, and I call half, half, half on it. So every time I call half, I divide the value by 2. So 8 becomes 4, 4 becomes 2, 2 becomes 1. I open the box and I get 1. Cool. Second example, I have 4. So 4 becomes 2, 2 becomes 1, 1 becomes It doesn't work. Okay. So when I get that, the state changes from some to none. And when I open the box, I get null. It's nice. Remember, I said we don't have any branching, and that's true. Look at the content of the method. There is no branching, but there is a change of state. It's not a coincidence, as you can imagine. This is called rel-oriented programming. Okay, it's just another way to handle errors in a functional way. And what we have here is just an illustration where you have 3 methods: validate, update DB, and send email. And this forces precedence. In order to send the validation email, we need to update the DB, and for that, we need to have a valid request. Okay, so as soon as one of those fail, what remains on the track will not be executed, because as soon as you fail, you end up on the red track where nothing happens. I'm going to show you. I have 2. I want to call half on 2. 2 becomes 1. I want to call half on 1. I can't. Well, at least I can, but it will return none. So now with none, I end up on the negative track. And when half needs to happen on the third step, nothing happens because I'm not on the green track, right? So you need to be on the success path to make sure that things happen. And it's exactly what you do when you do if-else statements one after the other to make sure that your flow is correct. The only difference is when you rely on if-else's, it's a horizontal stuff, and when you're using that, it's a vertical one. That's all, okay? And with binds, another celebration time, the box is now a monad. Because, as I said, it's a functor with something else, and the something else is the monadic bind, allowing you to change the state of what's inside the box. That's pretty cool. And honestly, I think we could stop there, but something is bothering me a little bit, because I don't like the fact that we rely on null. It's called the $1 billion mistake for a reason, right? And I'd like to have something else. And my question is, how do you represent the absence of a value if you don't rely on null? That's tough. The answer is you don't. What you do instead is provide a fallback scenario, a fallback value. And this is where match comes into play. And now match takes 2 functions on the parameter. Scary, isn't it? Actually, it's very simple. 1 function per state. And we're going to execute the function to extract the value based on the state we're in. Example, first one, you've seen that examples before. Sum3, increment, half, and then with match, I display every possible outcome. If the state is sum, I return as a string, the value is sum with the value. And if the value is none, I just return the value is none. There is nothing else to do. I don't have a value to evaluate. So in the first case, after match, the value we unwrap from the box is the value is sum3, and on the second scenario, the value is none. Okay, and that's already much better. We managed to get rid of null. I like that very much, and it would be a shame to stop right here. You know why? What can we see there? Functions. A lot of functions, okay? And the problem I see right here is this test, this function, call it the way you want, has quite a lot of things going on. The cognitive load is pretty high, and it could be interesting just to extract those, and it could look like that. So half was already existing, but value lambda value plus 1 can be increment. Value is sum can be converted to message. Value is none could be get default message for whatever reason, whatever name you can find out. Why do you want to do that? And well, it's fairly simple. We want to hide the details because what you're doing is more important than how you do it. Okay? Look at that. If you apply what we call declarative writing, your code is suddenly telling a story. When I read sum of 3, increment, half, I can show that to someone who's not a developer. They will probably understand, and Uncle Bob used to say that the ratio of reading versus writing code is well above 10:1. So you better make sure that you read faster and understand faster the code. And declarative writing helps a lot because it's telling you as a human what's happening. That's great. So if I now have to give you a more detailed explanation about what a monad is, again, it's my own. So it's not entirely accurate, but whatever. I'd say that a monad is a data structure that contains a value where you can have multiple states and you can manipulate the monad without knowing the states. And finally, you can have a sequence of operation that allows you to, for example, alter the state of the monad or keep the correct state. Now, what we've done there is creating our own. Obviously, you don't have to do that. There are plenty of libraries available. And the most famous one is LanguageX, which is probably my favorite nugget ever, I have to say. The other one are valid too, and yeah, don't write your own. Try to use one of those. And they all expose a set of different monads, and they all basically represent an opposition of states. Option is the one we built before that contains either some or none. We have try for exception and success, and we have a result with failure, success, etc., etc., etc. Plenty of options right there. What I want to show you is how can we simplify the initial example we had with a divide using those libraries. First off, let's look at try. So try will contain one of two states, which is going to be success or exception. Yeah, that looks pretty good. So what we're going to have here is basically if I call divide 50 by 0, it should be a failure because failure is an exception. It will throw an exception, right? And we can evaluate the message, the type, or anything. And 50 divided by 2 should be a success, where the value is 25. It's better, in my opinion. It's not perfect yet because we are still relying on exception under the hood. And again, we've talked about workloads, you know where I'm going. Let's try with another one. Let's try with either. And in that case, what I want to do is creating a specific record for my error and then return an error of either, error or decimal, okay? So in that case, what you can see is I'm not throwing anymore because I can evaluate if my statement will fail. So if it's failing, I'll return a new error, and otherwise I just do the division. And same, the only weird stuff here is given we have so many control because what we call left and right are generics, you can put literally what you want over there. They are described as left and right. By default, left should be the error side, but you're free to do the way you want, okay? Something I want to show you, look at the difference here. It's a side-by-side comparison of the initial example we had and on with the new thing, which we just made before, with the monad. We moved from 9 lines of code to 2 lines of code to handle the error and display it on the console over one simple example. I know the example was simple. Just imagine the effect on the scale of an entire code base. It's interesting. So wrapping up with monads, I think they're awesome and they bring plenty of things on the table. First off, referential transparency. I mentioned that as being something very, very important for me. It just means that you can always replace an expression by its value. And it was wrong with the initial divide because sometimes you got a decimal and sometimes you got an exception. And it was true with either, because even if it fails, we're going to receive an either. And this makes the code much easier to read and understand because you have less things to keep in mind and you won't have any surprises. Okay? We have less branching as well, thanks to railway-oriented programming. So obviously the branching is somewhere, it's in the box, okay? But when you're looking at a flow, you don't see it anymore and it's easier to follow. You know, it's a much more vertical approach. So yeah, better in my opinion. It encourages a declarative writing. I know it's not specific to monads, but it just, mix well together because we rely on functions. So I think you should do that because a function name tells more than its details, And finally, this one can create a little bit of controversy, but I like it because it forces you to deal with every possible outcome. It means you cannot have the equivalent of an empty try catch. And I personally think that when you have a problem, you should deal with it. So I like this one. Now, all these reasons there, all that, everything that a Monads bring to the table is not why you would like to try and maybe use Monads. What you want to look at are all the positive side effects. Easier to read, easier to predict, easier to maintain, less cognitive load, and smaller code base. We're talking about clean code stuff right there, okay? And this is something we try to achieve daily with different practices and all. And I think Monads helps a lot going into that direction. One more thing. This is what we had finally on the last example on the left. This is our C# code. I want you to look at how similar a F# equivalent is, okay? And what I found very cool with that is you're working in C#, you're just playing with functions and a data structure, and suddenly you're that close to jump on another language from another paradigm. And when you look at F#, as Scott Flashin used to say, it's like C# on diet, you know. So it's pretty interesting in my opinion. So now comes the tough part. Because right now you might say that, yes, indeed, in our examples, we focused on mathematical operations. It's very simple, and we all work in complex environment, and it wouldn't work there. I hear that all the time. So what I want to show you here is how I use Monads personally in my day-to-day. And I'm telling you, I'm using them a lot, everywhere. So first off, what is Vonage doing? Because I need to talk about that. Vonage is doing communication APIs. So if you want to send an SMS or a voice message or doing a video call or meetings or two-factor authentication, we have APIs for all that. APIs mean you can do a simple curl request or use Postman or just use a regular HTTP client to do the request yourself. Now, the problem is all that is pretty much boring. And if you've done that in .NET before, you know that using the client, creating the request, setting the body, the right stuff, the authentication, dealing with the response code, deserialize, it's boring, it's boilerplate, and nobody wants to do it. So I'm doing it for you. How nice is that? We actually introduced some tooling right there to basically simplify everything. So we transform all that boilerplate into a single method to call to do the thing. And this way you don't have to hustle. The good part is the SDK is open source. It's free. So if you want to look at how I do things, you want to complain, you want to contribute, you are more than welcome. And actually, fun stuff, Johan got his hands on it a few weeks ago with a mob in our meetup. That was very interesting. So what is my scope of action? Because it's an SDK, right? So my stuff, as I mentioned, is to simplify the way you can call an API. So it starts from dealing with the user input. And in that case, I'm doing what we call parsing. Parsing is transforming a less structured input into a more structured output. And in that case, it's basically a way to force people to go through my parsing mechanism to create a monad, and that can result into either a Vonage request to do something or a failure, okay? When I have my request, I convert it to an HTTP request. That just means adding authentication and another thing in the headers, nothing very fancy or interesting, and then sending it to a client. When I get a response, I can get either a success status code or a failure status code. And when I have my response, I need to deserialize it, and that can fail as well. Now pay attention to everything we have. That's basically everything. When I have the response, I can give it back to the user. But yeah, look at this and tell me if I'm paranoid or not, because I'm seeing railways, but do you? You see, it's not just for math. It can be used for more than that. And I'm going to guide you through the code that make that possible. So this is going to be the very heavy part of the talk, so buckle up, but it will be okay. First off, I mentioned parsing, dealing with the user input. What I'm showing right there is creating a flow for two-factor authentication. So first, I want to create a verify call request, and It's basically a builder. So I build it with the request ID and the code, and I create the request. It returns a result of verified code request. After that, I call bind to transform it into an HTTP request, an HTTP request, sorry. So notice how the type of the box keeps changing over time, right? I didn't put the code right there because I mentioned just authentication, user agent, blah, blah, blah. When I have it, I call the HTTP client and I get an HTTP response message. Notice that here we used map, and because it cannot fail. When you call an API, even if the call is a failure, it will never fail as an exception. You'll receive an HTTP response with a status code. So what I do here is I want to extract just the value I need on the response. And now comes the tricky part, because I'm sorry to tell, but I lied. Okay. In the previous slide, in the previous diagram, when I showed the railways, I have one scenario where I have more than 2 railways. I actually have 4, and I will explain why. So I just said that a HTTP response will never fail. You have to evaluate the status code. So I need to tell on my success path whether we received a success or a failure from the API, and after that, deal with the deserialization of each scenario. So success failure gave me 2 paths, and for each path I have 2 because I need to deserialize, and it can fail as well because something changed on the API, or my model is not up to date, or whatever. So I end up 4, 1 success, 3 failures. From the caller side, it's fairly simple. This is all there is. Create the request, send it to the client, do what you want to do with the response. Simple as that. Now, a question I got initially when I showed that on the first time is, what if I don't want to deal with monads at all? And that's a very valid question. I respect that. I try to make everyone happy. If you want to use monads and you want to use match and you want to be able to, let's say, make a sequence of operations, you can. If you don't want that and you want to rely on exceptions, I made a get success and safe method. It will extract the value directly from the box if it's in a success state, and it will throw an exception if it's in a failure one. So you can use good old exceptions if you want. The only thing you need to keep in mind is you can't predict which exception will happen at build time, at runtime, sorry. So it's like exceptions you need to prepare. And I mean, you're going to get stuff like that. But it's possible. It's up to you. Now, should you get rid of all exceptions forever because monads are better? Not necessarily. We need to have a bit more nuanced point of view here, because exceptions are everywhere, and like good old Thanos right here, they're inevitable. It's very difficult to write exception-free code. At least it's okay when you have control over everything. But as soon as you touch external stuff like dependencies or infrastructure code or middlewares or stuff like that, you're up for battle, okay? They're an integral part of the framework or a language, so it's tough to do without them. And honestly, and I'm sorry if I'm spoiling, but even Thanos got defeated by exceptions. So what can you do about it? I'm gonna show you how I do things usually using a real architecture for that, and I'm gonna rely on hexagonal or port-in adapters. If you've never seen this one before, what you need to understand is inside the hexagon is called the domain, where we have all the business logic. This is where the value of your software is. Okay, so pure logic, no dependencies anywhere, just business. What you have on the left outside of the hexagon is what we call driving adapters. It's the starting point of your application. A console app, a web app, an API, a desktop app, a service, anything that can run, basically. And what you have on the right is called driven adapters, and they are your external dependencies on which you have no control. Like you want to interact with a database, a third-party API, a file system, an external device, a printer, anything, everything outside your system. And trust me, they will throw tons of exception, whether you like it or not. And here my favorite is the one in the middle that comes from Entity Framework. When you try to save something and you have a concurrency problem and it's not able to update. And what will happen there is this exception will be populated to your domain up to your driving adapter. But for me, it creates a problem. Your domain, your hexagon, is supposed to be agnostic from all the dependencies. Suddenly you have something from Entity Framework going there. And, for me, I'm not a big fan of that. But it doesn't mean you have no option. For example, you could tell, right, exceptions happen, I have no control, but I have control about what comes in my system. And your adapter could catch all exceptions and return a try, a neither, a result, an option, anything. And you can try to keep your hexagon exception free. I've done that a lot and I like it a lot. It's not the only way of doing things, but I enjoy it. Now it's time to wrap up, and I just want to explain the reason that makes me want to do this talk. I wanted to expose an alternative to exceptions, because exceptions are the norm according to what we see, and it shouldn't. I'm not saying it's bad. It's like we need alternative to challenge things. So what I showed here, Monads, they are another tool that you can put into your developer toolbox. Developer toolbox is basically the knowledge we built along our career, and we fill that box with tools, practices, methodologies, and the more tools we have in there, the better suited we are to take good decisions. It's what makes us great engineers, right? So the more you have, the better. And I'm sorry to tell, but whether you want to throw exception or use monads, it doesn't matter. I kind of lied. I know, but it is what it is. What I want you to understand is this is just one way of doing something. What matters is something else, and I will explain. This is a quote from Mark Simon, one of my heroes. I was fortunate enough to meet him a few times. And it's a quote that I remember reading in one of his articles a long time ago, 2014, based on the link. And it was about command query separation, a very important OOP principle. And he was just saying that even though it's very important to apply CQS in OOP, it's sometimes okay to break it. And when he was breaking CQS, he was doing that willingly, right? And he knew he was making a trade-off. We work in a field that is very complex, where the only absolute answer you're going to get is, it depends. And it's important to know what you cannot do and what are the consequences. Take the quote, replies, decide to break CQS by decide to throw an exception, decide to use a monad for something. It's the same. You're allowed to break rules as soon as it makes sense. So what I want to focus on here, if you have one takeaway to remember after this talk, it's that one. Know why you're doing it. Whether you're picking exceptions or monads, know why you're doing it. Know which compromises, know which trade-offs you have to make to go there, and be able to defend your ideas. Explain that to your peers, your team, your mentees, others. You need to have strong opinions, right? So if you want to throw exceptions and you know why, good for you. You want to use monads and you know why, good for you. So don't blindly follow what some guy, some stranger at the conference or at a talk is just saying. And I'm talking about me. Don't trust me. Forge your own opinion. Try, experiment. And what I want you to do is not to apply monads. I want you to try monads, okay? So make your own opinion and then see what fits better depending on what you need and depending on what you're working on. Right, so a few things I'd like to share. I'm currently writing a series of blog posts about monads where I kind of explain what they are, and we, again, increment on that and try to go to things more and more complicated. Currently, there are 2 more will come in January, February. So if you're curious, feel free to take a look. Also, plenty of resources right there, including books, articles, link of the SDK or of the talk itself. Every snippet you've seen today in the talk are from a repository that you can clone, and everything is executable because it's all tests. Okay, so it's perfect to try. That was all from me. So thank you very much. I hope you enjoyed the talk. And well, if you have any questions, feel free to let me know. I'll be happy to answer.
Yeah, thank you, Guillaume. Thank you for that. Fantastic talk. Thank you. Yeah, it's in the chat.
Yeah, I'm just going to share the link for the drive here, where you're going to find a text file with all the links and the basically the PDF of the talk if you want to review it. So feel free to look at that. I've seen a question before in the chat.
You have one from Arif.
Okay.
Where are you? Yes, the original question was, this is you generally at a test area or not? And basically, I said to Arif, maybe Arif, you can ask your question if you are still there, maybe to expand your thought. It was about controlling the response, but yeah, I don't know if it's clear, if the question is clear for you.
I think, if I'm understanding well, maybe he's referring to sessions, because I see equal B is generally Mocha test. What you've seen, Arif, in many of those snippets, I wanted them to be executable. So I put them in some test, and to make sure that everything is a bit smoother, I used fluent validation. So when I was doing box.yada yada yada .openbox, I was receiving an ENT, a value or null. And basically after that, having should be is just like a shortcut, syntactic sugar to make an assertion in a test. Okay. So it's not part directly from the monad, but it was a way for it to be a bit more elegant, if I should say. So it's this should, when you have should be, it is in the test area. The rest is not. The rest can be literally anywhere. Let me know if I answered correctly. I just want to make sure that I didn't say anything completely off the chart.
Okay, cool. And I wanted to go back to what you said regarding the session we had maybe previous week or 2 weeks ago, because yeah, we did an interesting session in which we were, I think, 4 to explore your code base, and we had some toolings. So everything is available in your in Vonage repository. I say yours, but in Vonage's repository. And what was interesting is we looked at some tools like a code scene, mutation report from Striker. We took a look at Sonar Cloud as well. And what I was looking for was because I was the one on Sonar Cloud, I was looking for complexity. I was searching for complexity in the production code. And what is really interesting is because you you use Monads everywhere. Yeah, I found no complexity in the code. What I mean by complexity in Sonar Cloud is really cyclomatic complexity. So basically, calculation based on if else choice in the code. So what was really interesting, because we have seen no complexity because of that.
Yeah, it's exactly. So it measures the cyclomatic complexity, which is the number of paths the code can take in your method. And when I mentioned that with Railroad we don't have any branching, it's not a lie. It's just a sequence of operation. I aligned them vertically because it's elegant, but they are basically a one-liner. So when your tool goes on that, it doesn't see any branching right there. So for him, the entire sequence is like one path and that's all. It doesn't mean the branching disappears, but you have to think that when you have, for example, if I'm taking the example we had with increment, half, etc., every time you have an if else, it will be obvious. They are here, but they are just hidden in the box. And you have to imagine that it's like, instead of having tons of if else's, we kind of shrink down the volume, put that into the box, and it's basically invisible, and it's part of the mechanism of the monad. And suddenly you don't focus about that anymore. You just focus on, what is my code doing? You know, I have entire flows where I do several calls and I get stuff back, and it's just transformation with side effects, because we're not in a functional language and we have to deal with that. But it makes things much easier to understand. And for the metrics, I don't want to focus on the vanity, you know, that it's good to have good metrics, but they have to be useful. And here I can feel the good side effects of that, because for me, it's easier to understand. I'm also used to it. It helps a lot, I know. But I agree with you. For me, it's really a game changer. And usually when people see that, they think it's not possible. But the code is just another dimension. If you use tons of if else's, you go on the right, and here you go down. But at the end, it's just the same. The branching is just done inside the box. For me, it literally changed the way I approach software engineering entirely.
Yeah, good point. Do we have another question?
Feel free to ask, it's free. And otherwise, yeah, so plenty of links right there if you want to look at it. If you want to see Monads in action, my code base is open source. Go ahead, have a try. Or use the code base from the talk and run it and modify, experiment, try things. Note something that I didn't say that, but for my SDK, I didn't use any of the libraries I showed. I built my own monads for my own reasons. So don't be afraid if you look at that and you don't see any exact like equivalent somewhere. Just saying.
Okay, cool.
Thank you, Kevin and Romain, for your feedbacks. Arif as well, Egveni as well. Really appreciate. I hope you had a good time.
Yeah. I think we can close here. Thank you again, Guillaume.
My pleasure.
See you next time.
Yeah, until next time. Yeah, who knows?
Bye. Ciao.
Have a good evening, everyone. See you soon.
Yeah, have a good evening. Yeah, bye.
I close the record.
Tu l'avais lancé aussi de ton côté? Attends.
Non, non.